Imagine you are standing at the bottom of a swimming pool. You already know that pressure increases as you go deeper. But here a question, how do we know that? Who measures that pressure? And if pressure is invisible, how can we possibly measure it? Can we hold the pressure in our hand? Can we see it? Can we weight it? Today we are going to uncover one of the most fascinating idea in fluid mechanics. How do we measure pressure? And by the end of this video, you will understand the working of two important devices, manometer and barometer, without memorizing anything. Because here at DK Physics, don't memorize it, visualize it. Leo is walking through a laboratory. He sees different instruments. For temperature, a thermometer. For a mass, a balance. For a time, a clock. For a length, a scale. Every physical quantity seems to have a measuring instrument. But what about pressure? Leo stop and think. Pressure is invisible. We cannot see it. We cannot touch it. So how do you scientists measure it? At a first, this seems impossible. But nature gives you a clever clue. Imagine a tube filled with color liquid. Now suppose we apply pressure on one side. What happens? Liquid start moving. One side goes down, the other side rises. Interesting? The pressure itself is invisible, but its effect is visible. Pressure can push liquids, and this simple idea formed the foundation of pressure measurement. Scientists realized if pressure can move a liquid column, then maybe the amount of movement can tell us how much pressure is acting. And the idea led to one of the simplest pressure measuring device ever invented, the YouTube manometer. Look at the U-shaped tube. It is partially filled with the liquid. Suppose one side is connected to the gas container, the other side is open to the atmosphere. Now imagine the gas pressure increases. What happens? The gas pushes the liquid downward on one side. As a result, the liquid rises on the other side. A height difference appears. And here's the important observation. Greater pressure produces a greater height difference. So instead of directly measuring the pressure, we measure the height difference of the liquid column. The liquid itself becomes the pressure indicator. This device is called a manometer. Now come to the physics. We already know something important from the previous video. A liquid column of height h produces a pressure because of its weights. The pressure produced by the liquid column is P equals to rho gh, where P is density of liquid, g is acceleration due to gravity, and h is height of liquid column. This means taller liquid column corresponds to a greater pressure. So in a manometer, by simple measuring h, we can calculate the pressure difference. That's why manometers are widely used in laboratories and industries, not because they are directly show pressure, because they convert pressure into a measurable height. Beautiful, isn't it? At this point, Leo noticed something strange. Even when no gas is connected, the atmosphere itself is exerting pressure. Wait, air has a pressure? The air around us is constantly pushing on everything. On our bodies, our buildings, on oceans, on mountains, everything. But if atmospheric pressure exists, can we measure it too? The question takes us one of the greatest experiments in physics history. Imagine a long glass tube completely filled with mercury. Now the tube is inverted into the bowl containing mercury. Something surprising happens. The mercury level inside the tube falls slightly. Then it stops. Leo wonders what is holding the mercury up. Gravity is trying to pull it down, yet it doesn't completely fall. Why? Because atmospheric pressure is pushing upward on mercury in the bowl. The atmospheric pressure is literally supporting the mercury column. The height of this mercury column tells us the value of corresponding pressure. This device is called a barometer, the instrument used to measure atmospheric pressure. At sea level, the measuring column settles at approximately 76 cm. This means atmospheric pressure can support mercury column of its height. Using the relation P equals to rho gh, scientists calculate atmospheric pressure to approximately 1.01 into 10 raised to power 5 pascals. This value known as 1 atmosphere. It comes from the weight of Earth atmosphere. Now let's see where pressure measurement is used. In hospital, doctors use pressure measurement device while monitoring the patients. Blood pressure measures are based on the pressure difference inside the artery. Aircraft constantly monitor cabin pressure and external atmospheric pressure. Without accurate pressure measurement, safe flight wouldn't be possible. Factory uses pressure gauge and manometers to monitor boiler, pipeline and gas system. A small pressure change can prevent a major accident. Scuba diver must monitor water pressure at a different depth because pressure increases rapidly underwater. Understanding the pressure literally keeps them safe. Let's summarize. Pressure is invisible, but pressure can move fluids. Scientists use this effect to measure pressure. A manometer measures pressure by observing the height difference in a liquid column. A barometer measures atmospheric pressure using a mercury column. And both devices rely on one simple idea. Pressure and liquid column height are related through P equals to rho GH. What happens as an invisible force becomes measurable through clever physics, and that's the beauty of science. We cannot see pressure, yet we can measure it. We cannot touch atmospheric pressure, yet it supports a column of mercury. Physics allows us to understand invisible world around us. And once you visualize it, you never need to memorize it. I'm Dipanshu from a DK Physics, and remember, conceptualize, visualize, conquer. See you in the next video.